Team at Organizational Design Community that's bringing these webinars to you. It's my pleasure to introduce Professor Maciej Workiewicz at the ESSEC School of Business. Maciej is one of the people at the leading edge of thinking about how AI and machine learning might influence what we do as students of organization design. And he's very kindly agreed to put together this introductory workshop or webinar, where I think his ambition is to take people who know practically nothing about AI and ML and get them at the end of 90 minutes to feel reasonably confident that they know where to go next. Is that reasonable, Maciej?
Yes, yeah, that's the ambition.
Excellent. Thank you so much for doing this, and over to you. Please manage the time as you see fit.
Okay, thank you very much, Fanish, for the introduction. So first of all, welcome everyone to this webinar series. I'm very excited today to speak to you about this topic, which was intended to kind of cater to a diverse community in the organization design community. There are individuals who do research, academics, but also practitioners. So the intent for this session is to make this topic of machine learning, a little bit more kind of, bring it closer to what it is, what can we get out of it, and discuss some kind of differences with maybe some tools and approaches which are more familiar to us who kind of grew up with statistics. So just a few maybe words about myself. As Fanish said, I'm an associate professor at the ESSEC Business School, where I teach strategy and management. I also teach organization design, organizational theory, organizational learning, computational modeling, and machine learning. So that's part of my portfolio. And today, what I prepared for us is sort of a four key topics, or kind of four pastures that we're going to explore together as an introduction to the topics of machine learning. So the first one is I wanted to provide some background in terms of what is machine learning, where did it come from, how does it relate to other topics, like, for example, artificial intelligence, where very often those two terms are used interchangeably or kind of as synonyms. I also want to get our hands dirty a little bit, as the title of this session already proclaims. It will be my hands that will get dirty, so I'm gonna work through the exercise with you, but it will be your eyes and that will be directing those hands. And this exercise will hopefully show us kind of closer what is the logic behind machine learning algorithms. Then what we're going to discuss is some key differences between machine learning approach, or the algorithmic approach, and the statistical approach, which we sort of know from the classes like econometrics. And then at the end, the last theme will be to discuss the applications of machine learning, particularly for research. I know that there are several doctoral students and faculty here. So how can we use those new methods in our work? But before we begin, what I wanted to do is to start with a quick survey, just to get to know you better and who is on the other side of the stream. So let me just launch a quick poll. There are 3 questions to answer, just to kind of see whom to cater to today's session. So now you should have received the window. Okay, I can already see the votes coming in. Okay, I think we have still a few people to answer. Okay, I think we can finish polling at this point. And let's share the results. Okay, so we have overwhelmingly academic researchers here, but we still have several people who are interested in practical applications. In terms of knowledge of the machine learning, we have one person who has high, okay, 5 medium, most of you have low or non-existent. So this is good, that's the right session. You're in the right place. And your current programming skills, also most of you know some programming, but maybe not as well. Okay, I think we can therefore proceed. Okay, so I'm going to sort of moderate here my delivery with those points in mind. But certainly the session is not, I mean, don't worry, it's not a session dedicated to those, to experts. This is a really sort of a beginner level. I also wanted to do a little bit of housekeeping before we begin. If you have any questions throughout the session, because there is quite a few of you, perhaps we can use the chat functionality for questions. If you have a particular question regarding maybe a topic, you can share it through the chat. Then at the end, I would keep the Q&A for the end so that we don't kind of lose the momentum through the session. Okay, so if that's clear, we can therefore begin. Let me just kind of switch here to a different view. Can you see it clearly, the presentation? Okay, if it's a very small window, you can choose to magnify the person speaking. Okay, so let's begin. So first, let's talk about some background for machine learning. Where did it come from, and sort of what is behind it? So first, what I wanted to kind of discuss is just, very quickly, what is the difference between machine learning and other topics related to it, like artificial intelligence? So very quickly, artificial intelligence is generally a field of computer science that is building systems which exhibit human-like intelligence. So they perform sort of intelligent tasks. We can distinguish between a general and a narrow AI. So a narrow AI is, let's say, a system that can recognize photographs or maybe classify images. It's a human-like activity, let's say recognizing handwriting, and we already have systems that can do it very, very well, but they are very narrow. They can only really perform a task for which they were trained. Of course, the holy grail is to create a general AI that can exhibit human-like intelligence or perform intelligent tasks of multiple varieties. But that we don't have yet, and and that's still just in the area of science fiction. Now, machine learning is a technique to process information where you can have the machine learn just by looking at or by analyzing the structure of the data itself without being programmed to perform certain actions. And as such, it is one of the ways to achieve artificial intelligence, but not the only way. There are other types of systems. You can have sort of more sort of logic-based systems which use kind of if-then statements that can also perform some of the human-like tasks. But machine learning is one technique that particularly over the past maybe last decade or two has really gained prominence, and why we will discuss just in a moment why this one moved to the foreground. Finally, there is something that I just wanted to also sketch here because many people now are interested about the deep learning neural networks. And what is this? Well, neural network is just the one type of machine learning algorithms. There is a lot of machine learning algorithms that not only the neural nets, but neural networks have particular power, especially for practical applications that together with the availability of large amounts of data made them very powerful, at least since the, let's say, 2012, 2011, when those algorithms really started to show their power. Now, I don't know if I have to introduce this gentleman, but he's going to play a quite important role in our story here. So that's Herbert Simon, who, as you know, for us organizational scholars, is definitely a very important figure. But I bring him here because actually a lot of the story started with him. He played a very prominent role not only in our field of organization theory, but also in the field of artificial intelligence and computer science. He was one of the first sort of researchers, also participated in the now famous or historical conference at Dartmouth in 1956, where the term artificial intelligence was coined for the first time. And I brought him here because, you know, the field of artificial intelligence or machine learning in particular had already seen a lot of hype. And, you know, it's probably right to be skeptical when you're asking yourself, you know, should I come to this session, machine learning? What if it's, you know, just another sort of Bitcoin craze and it's going to go away soon? You know, this field has already seen many of hype cycles. You know, even Herbert Simon famously said in '56, exactly at the conference, that machines will be capable to do many type of tasks that humans do right now in about 20 years. Probably he overshot a little bit. That's, you know, we have sort of seen this wax and wane, and the whole field of machine learning and artificial intelligence went through several cycles. And I think it's important to understand the historical perspective here. So as I said, in the 50s, the field was born. It was the time when the first models were created. For example, perceptron. So when you think about neural networks, they go all the way back to the 50s when the first models like perceptron were created, which are the building blocks of neural network. That was also the time when there was quite a lot of research in cybernetics, or in the sort of the science of complexity. So a lot of the models sort of came from there. Simon, but also Newell, Shannon, Wiener, Minsky, these were the kind of people who really created this first kind of burst. But it came to an end. In about sort of late 70s, there was so-called first AI winter. And the reason for this was quite prosaic. If you sort of remember the business history, 1970s were the same time when personal computers were created. So Apple, the first machines, this has pretty much dried up all the funding for the companies that were previously building big mainframe computers. Because before the PCs, we had those big mainframe computers. So the Cray, for example, systems, they were creating those supercomputers, which were used by the AI researchers extensively. And with the collapse of this industry, also came the collapse of the AI research, as the personal computers, as cheap and as wonderful they were, they had not enough computational power to really move the research forward. The next kind of a boom came in the 80s, where there was emergence of other systems like expert systems, which were sort of based on human knowledge, trying to codify human knowledge for decision making. There was a lot of competition between Japan, US, UK. Again, this came to stop. There was a second AI winter. Again, problems with hardware. Usually theory was way ahead of the computational power, so many of those models were just not practical to deploy. Also, the data was not there. However, this started to change with the advent of internet in the 90s, and also the growth in computational power. And many companies started investing more and more into those systems. And you may kind of remember the famous game between Garry Kasparov and the Deep Blue in '97, when the machine for the first time won in the game of chess. And after that, actually, we did not have another winter. There was some kind of expectations that we may enter another one, because the amount of data produced by internet and connected devices, and the digitization of companies of the world around us has led to a huge amount of information, and also the computational power. Particularly, we can thank computer gamers for the wonderful gift of graphical cards, which are used extensively for machine learning applications. All of those advances in both hardware and data has led to what we still undergo, which is a machine learning revolution. Now, of course, you know, it is, I think, worthy to ask, okay, is it just another hype? And probably there is. Humans have this propensity to usually overshoot our expectations early on as we sort of climb the Dunning-Kruger, you know, mountain of wisdom. And then sort of the reality comes back to us. We see that every method has its limitations. Every method has to be applied carefully. But at some point we find this plateau of productivity. I think with the machine learning tools, we are, depending on which maybe type of machine learning, we have either reached the plateau of productivity or we are heading there, because I think a lot of the characteristics of models are already known. And like I've said, many of those models are actually quite old. They were just waiting for the data. They were just waiting for the hardware to really show their strength. And I think I just sort of wanted also to mention here one kind of more sort of humorous note, that the progress in this field has been so fast that it has been catching sort of us humans sort of unawares. Pretty much every task that we have imagined that will be the red line for the AI. So AI will not be able to do, I know, compose music or paint pictures or do art, has been shattered. And the power of those systems, which are particularly based on machine learning and the deep learning, has been really astounding. So I think that for the applications of us, researchers and practitioners, they are of particular value, especially that the tools to build those models are easily accessible and free for most part. So if you want to get involved with machine learning, these are pretty easy to pick up skills, and you don't need to sort of buy any expensive hardware or very expensive software to start playing with the AI or machine learning. So speaking about progress, it has been really breathtaking. I mean, it's very hard to keep up. This slide was like current maybe a year ago. It's no longer current. I have to add a few more breakthrough kind of milestones for the machine learning algorithms. They not only have already achieved supremacy compared with humans in image recognition or speech recognition, translation. One of the more recent ones was actually the solving the protein folding problem, which was one of the kind of very, very tough problems in molecular biology. And Google team has actually managed to come up with a machine learning algorithm that can predict how proteins fold, which will have huge implications for also medical research among many. And machine learning has been ubiquitous and very powerful. I think that most of you are users of at least some of those services. So you know that we humans already got used to using machine learning to recommend us books, movies, music, to tell us where to go, where to work, or even which romantic partner to choose. So very, very prevalent and ubiquitous in terms of their use. So they have been transforming the world around us, economies around us, but also organizations, changing the way that work is done inside of organizations. I think this is still very early. I mean, those changes are still at the very early stage, but there is, I think, a lot of promise in terms of using those algorithms to help not only design, but also run organizations. And particularly, one kind of example that I would like to share with you here that really kind of made me think about, the role of machine learning is this is this sort of new algorithm, AlphaZero, which was developed by the Google team, which had the algorithm learn playing chess from scratch in about 4 hours and beating every other best chess program in the world. Now, why you have to beat another chess program is because humans are no longer in the even top 10 of the chess players. Pretty much all the best chess players on planet Earth are algorithms. And AlphaZero managed to beat the best of them after only 4 hours of self-training. And one particular comment that came from the expert in the field was sort of the astounding power of those algorithms. That those algorithms can not only detect pictures or detect voice or handwriting, but they can also help to run organizations. And here actually, is kind of, is quite a high claim that such algorithms can not only run entire cities or continents, but even universes. So definitely there's a lot of, perhaps hype But again, since we already seen how much those algorithms have achieved, I would say that we have to take such predictions quite seriously. It's probably just a matter of time and not if, judging by how quickly this field is developing.